It's the GCSE Maths High Tier Calculator Paper 3 from November 2023. Let's get straight into it. Question 1. Write 468,000 in standard form. Whenever we write numbers in standard form, the first number needs to be greater or equal to 1 and less than 10. So for the start, I'm going to choose 4.68. And then we need to write times 10 to the power of something. So right now, the decimal point is between the 4 and the 6 over here. We need to move it 1, 2, 3, 4, 5. So it would be 10 to the power of 5. Part B, write 5.037 times 10 to the negative 4 as an ordinary number. Whenever you have a negative in standard form, this is telling you how many zeros you're going to have at the start of the number. So it's going to be 0.000, that's 4 zeros, and then you just write 5037. Question 2. Here is a biased spinner. The table shows the probabilities that when the spinner is spun, it will land on A, on B, on C, and on D. Luca will spin the spinner 200 times. Work out an estimate for the number of times the spinner will land on A. So the expected outcome, the formula that we use here, is the probability multiplied by the number of trials. So here the probability is 0.4. You're multiplying it by the number of trials, that's how many times you're doing it, that's 200, and that would be 80. Question 3. Sager works at a weather station. The table gives information about the temperature at midday for each of 50 cities in the UK on Tuesday. Calculate an estimate for the mean temperature. So we have the grouped frequency table here, so we need to find the midpoints of these two numbers first. The midpoints of 10 and 15 is 12.5. If you're not sure, you can do 10 add 15, which is 25, and you divide it by 2. So you're just finding the mean of those two numbers. For that one, it would be 17.5, that'd be 22.5, that'd be 27.5, that'd be 32.5. So we're just going to use all of these to find our fx column. So we multiply our frequency by our x value. So multiplying these two together, 12.5 multiplied by 2 would give us 25. And 17.5 times by 8 is 140. 22.5 times by 13, 292.5. 27.5 times by 21, 577.5. 32.5 times 6 is 195. When you normally work out mean, you add up all of the numbers and then you divide by how many there are. So here we're going to add up all of these and then we're going to divide by how many there is. There's 50, and that would be the same as if you added up all of these. Let's add up these first. So we've got 25 plus 140 plus 292.5 plus 577.5 plus 195, which is 1230. Then we need to divide that by 50. And just before we do this, let's just have a little guess where it should be. I can see that a lot of them are around here, and that's around the middle. I'm guessing the answer should be somewhere between 20 and 30. So 1,230 divided by 50, which gives me 24.6. And that looks quite good because it was somewhere where I estimated it would be. Sager says the median temperature is 22.5 because 22.5 is the middle number in the middle group. Is Sager correct? Give a reason for your answer. So Sager has thought that if we look at this middle row, which is this one, and we find the middle of those two values, which is 22.5, that would be our median, but that's not true. We need to find the middle of 50 values. So we just divide 50 by 2, which is 25. We're looking for the 25th position. So where would the 25th position be? Is the 25th position in this first row? So far, we've had 2 as our frequency. That's not enough. If we add 2 add 8 together, we get 10. That's still not enough. 10 add 13, which is 23. That's still not enough. And if we add 21, we get to 44. So our 25th value is somewhere within this range. It's between 25 and 30. The answer is no. The median is in the group. We just copy this out. So t is greater than 25 or less than or equal to 30. So t is greater than 25, less than or equal to 30. Question 4. Jenna is asked to show the inequality x is greater than -3 and less than or equal to 4 on a number line. Here is her answer. So we can see on her number line, she's put a circle at -2, but that circle needs to be at -3. So you just need an empty circle. For the one at 4, she's put it in the correct position, but we need to fill it in. Because there's more pen on here, we need to put more pen on here. We just need to color that in. Write down 2 mistakes that Jenna has made. So I've just explained that. There needs to be an empty circle at -3. And for the second one, this circle at 4 should be coloured in. Part B. Work out the greatest integer that satisfies the inequality. So integer just means a whole number. It means our counting numbers like 1, 2, 3, 4. So we're just going to solve this. Just imagine that's at equals. We're going to first think what's happening to this y. It's being multiplied by this 5 and then we're taking away 7. So we're going to do the opposites to that. We're going to add 7 first to both sides. So 5y is less than 16 add 7, which is 23. And we need to divide both sides by 5. So y is less than 23 divided by 5, I'll write it as a decimal just so it's easier. That would be 4.6. We want an integer that would satisfy this inequality. So we want the number that's slightly smaller than 4.6, that's a whole number. So the answer for that one would be 4. Question 5. Ali buys packs of balloons and boxes of pencils. There are 30 balloons in each pack and there are 24 pencils in each box. Ali buys exactly the same number of balloons and pencils. Work out how many packs of balloons and how many boxes of pencils she should have bought. You must show all your working. So whenever I'm doing this question, I'm first thinking, am I looking for my lowest common multiple or my highest common factor? Because I'm repeating, I'm finding out how many boxes I need to buy and how many packs I need to buy. It's going to be a lowest common multiple question. So I'm trying to find the lowest common multiple of 30 and 24. So if you want to, you can just list these out, and sometimes you might find that it's very close to the starting number, and in this case it would be. I'm not going to use this method because I don't think it's appropriate for all situations. An easier way to do this if you have larger numbers is the index method. So I'm going to first find the prime factors of these using my calculator. So I've got 30 is equal to, so I just write 30 and then shift fact, which gives me 2 times 3 times 5. And then I'm going to do the same thing with 24. Shift fact, which gives me 2 to the power of 3 times by 3. And now all I need to do to find the lowest common multiple is find the highest power of each unique factor. So a unique factor here is 2. And the highest power of that would be 2 to the power of 3. For the 3, the highest power is just 1. For the 5, it's just 5. So if I multiply all of these together, 2 to the power of 3, which is 8, 8 times 3, which is 24, and 24 times by 5, which is 120. So that's my lowest common multiple. And if you want to check that, you can just do alpha and press this lowest common multiple button over here, and it'll bring up this. Press 30, and you want comma, which is shift and this bracket button, and there's a little comma above it, 24, and that tells you it's also 120. But you can't just do this, you need to show the working out for it. But that just confirms that it is 120. That means we need 120 balloons and we need 120 pencils. So let's do the balloons first. We'll do 120 divided by 30, and that's telling us how many packs that we need to buy. That would be 4. And for the pencils, we're going to do 120 divided by 24, and that would be 5. So we need 4 packs of balloons and 5 boxes of pencils. Question 6. A company orders a large number of plates from a factory. It would take 30 hours to make all the plates using 4 machines. How many machines are needed to make all the plates in 6 hours? The first thing that I need to think about is how long would it take if I have 1 machine? So because I've divided this by 4, I need to do the opposite of that to this one. I won't divide it by 4 because that would mean it would be quicker to do it with 1 machine than 4 machines. So I need to multiply this one by 4. So that would be 120 hours if I have 1 machine. We want to try and get it to 6 hours. So we need to divide this 120 divided by something, which gives me 6. That would be 20. So on the right hand side, I need to multiply that by 20. So 1 machine times by 20 would be 20 machines. Question 7. Riley travelled by car and by aeroplane. He travelled 143 miles by car at an average speed of 50 miles per hour. Riley then travelled for 5 hours and 20 minutes by aeroplane. Work out in hours and minutes Riley's total travelling time. So we're going to be using our distance, speed, time formula triangle. We have our distance and we have our speed, which is those two. So we're trying to find the time for that first part of the journey, the car. So we're doing distance divided by speed. And here the distance is 143. That's been divided by 55. And remember, this is going to give us an answer in minutes. So 143 divided by 55, which is 2.6. So it's 2.6 hours. To convert this into minutes, we just multiply it by 60. That's 156 minutes. So how many hours and minutes is that? So that's going to be 60, 120. So that's 2 hours. We're on 120, and and we need 36 more to get to 156, so 36 minutes. We're trying to find the total travelling time, and Riley travels for 5 hours and 20 minutes more. So we need to add 5 hours and 20 minutes more to that. So 36 add 20, which is 56 minutes, and 2 plus 5, which is 7. So it's going to be 7 hours and 56 minutes. Question 8. The diagram shows a solid cube placed on a horizontal table. The pressure on the table due to the cube is 3.5 newtons per centimetre squared. The force exerted by the cube on the table is 504 newtons. Show that the total surface area of the cube is less than 900 centimetres squared. So first thing I need to do is think which of these I'm trying to find. I'm trying to find the area, so I'm just going to think of this area as x, because that's what we're trying to find. We know what the pressure is. The pressure is 3.5. That's going to be equal to the force. The force is 504 divided by x. We need to remember this x is just the area of one of the faces on that cube. Let's just solve this equation. So all we need to do here, we can swap these two values with each other. So this x will go over to that side, and this 3.5 will be below this 504. So it's x is equal to 504 divided by 3.5. So 504 divided by 3.5, which is 144. This is saying that the area of one of the faces, this bottom face, is 144 centimeters squared. We want to try and find the total surface area of the cube. So how many faces are there on a cube? There's going to be 6. So we multiply 144 by 6. See what that gives us, 144, hoping for an answer less than 900, and it's 864. So 864 centimeters squared. And we just write a sentence that shows that we understand the question. So 864 is less than 900. Question 9. The line L is shown on the grid. Find an equation for L. So the formula for equation of a line is y is equal to mx plus c. There's two parts of this that we need to find. The gradient, which is how steep the line is. For every one across, how much does it go up or down by? And the c value, which is the y-intercept. This one's a little bit easier. Where does it cross the y-axis? Let's do the c value first because it's easier. That's going to be at 3. So c is equal to 3. The gradient just means for every one across, how many does it go up or down by? Or you can do rise over run. But because we've got a nice graph here, it's just easier to do this first method. So I can see for every one across, it goes down by 2. So that means the gradient, the m value, is negative 2. All I need to do now is substitute both of these in, and I get my equation. So y is going to be equal to, this m changes to negative 2, x, and my c value is 3. And one way you could check this is if x is 2, we should get a y value of negative 1. So we'll substitute it into here and see what we get. So negative 2 multiplied by 2 plus 3, so that's negative 4 plus 3, which is equal to negative 1. So that just confirms that's true. You could check another point as well if you wanted to. Question 10. Make m the subject of k is equal to p plus 2m over 5. So we're trying to get this m on its own. So what's happening to this m? It's being multiplied by 2 first, it's being divided by 5 afterwards, and then we're adding p to it. So we're going to do all of those things. We're going to take away p, we're going to multiply by 5, and we're going to divide by 2. So let's take away p first from both sides. So take away p from there, take away p from there. So it'll be k minus p is equal to 2m over 5. So that's that first one done. We need to multiply both sides by 5 now. Multiplying all of this by 5, we would write it as 5 bracket k minus p is equal to 2m. That's got rid of that divide by 5. And you don't have to expand that bracket. You can expand it if you want, but it's not worthwhile. You won't get any extra marks for it. So we've done that second one. We just need to divide by 2, the opposite of that. So divide by 2 there and divide by 2 there. So it's 5 bracket k minus p. That's all over 2. That means divided by 2 is equal to, that's being divided by 2 as well, m. And you can see we've got m as the subject because m is on its own. Question 11. The floor plan of a house is drawn using a scale of 1 to 50. On the plan, a room in the house has a floor area of 48 centimeters squared. Work out the real area of the floor of this room and give your answer in meters squared. Let's first think, what is our length scale factor here? From 1 to 50, what have we multiplied by? We've just multiplied by 50 there. And if we want our area scale factor, because we're looking at the floor area, the area scale factor will be my length scale factor squared. So I just need to square this. So I'm doing 50 multiplied by 50, which is 2,500. I know my area on my plan is 48. So I just need to multiply that by 2,500, and that will tell me what the area is in real life in centimeters squared. So 48 multiplied by 2,500 is 120,000. This is in centimeters squared. If we look at the question, we want it in meters squared. So how do we normally convert centimeters into meters? We know 100 centimeters is the same as 1 meter, so we need to divide by 100. That's for lengths. If we're doing areas, we need to divide by 100 squared, which is the same as dividing by 100 with 2 more zeros, so that'd be 10,000. So I just need to divide this by 10,000. 120,000 divided by 10,000. You can just cancel the zeros out. So I'm left with 12 divided by 1, which is just 12, and that would be in meter squared. That seems appropriate for a room area. Question 12. The diagram shows a shaded sector POQ of a circle with center O and radius 6.2 centimeters. The area of the shaded sector is 82.6 centimeters squared. Calculate the size of angle X, give your answer to 3 sig fig. So the formula we're using here is the area of a sector. So formula for area of a sector. All that is theta divided by 360, or the angle divided by 360, the fraction of the circle that we have, multiplied by our formula for area of a circle. What's our formula for area of a circle? So cherry pie delicious for circumference, and apple pies are 2. So pi r squared. We just need to find what this theta value is, what our angle is. So we're going to substitute the values that we do have, and then we'll find out what theta is. We know that the area is 82.6, so 82.6 is equal to theta, I'm just writing it as x, divided by 360, multiplied by pi, multiplied by our radius squared, which is 6.2 squared. Just need to solve this now. So x is being divided by 360 and then multiplied by all of this. So I'm just going to move all of this first to that other side. So because it's being multiplied by all of this, I'm going to divide that by all of this. So 82.6 divided by 6.2 squared multiplied by pi is equal to x over 360. So x is being divided by 360, just need to times it by 360. So I can write it as 82.6 times by 360 over 6.2 squared times by pi. That will give me my x value. So let's type all of that in. 82.6 multiplied by 360 over 6.2 squared multiplied by pi, which is 246.2347. So x is 246.2347. The question wants it to 3 significant figures. So significant figures just means the first one that isn't a zero. There aren't any zeros here, so we'll just count from the first one. 1, 2, 3. That means we're rounding at this decimal point. Because that's a 2, it's going to round down to 246. So the angle would be 246. The way you could check this, you could substitute 246 back into here, and you should get an answer of 82.6 centimeters squared. Question 13. Alan grew 80 plants of the same type outside. The cumulative frequency graph shows information about the heights in centimeters of these plants. One of these plants is chosen at random. Find an estimate for the probability that this plant will have a height greater than 90 centimeters. So where's 90 centimeters on this? It's somewhere between 75 and 100. If we find the middle of those two values, half of 25 is 12.5, so I know 87.5 is over there. And there's 10 gaps, so each gap will be worth 2.5. So the one after 87.5 will be 90, so I'm looking for that one. I'm going to draw a line going straight up, going up from 90 to where it touches the line. And then I'll draw a line going straight across. And it would reach there. So now I need to figure out this y-axis. What's my scale? I've got 10 gaps between 60 and 80. 10 gaps which is worth 20. So each gap is going to be worth 2. I'm going to count up from the middle. That would be 70. So that would be 72. And that would be 74. And this is saying there's 74 plants with a height less than 80. Heights that are greater than 90. So we want to read above there. So 80, take away 74. Which is 6, and we know there's 80 altogether, so we're going to do 6 over 80. That would simplify to 3 over 40. So the probability of having a height greater than 90 centimeters would be 3 over 40. Part B, use a graph to find an estimate for the median height. So we need to find the middle value here, and we know altogether there are 80 values. So the middle value will be my 40th value. I just need to do 80 divided by 2, which gives me 40. So I'm going to read across from there. So it touches the line here. Draw a line going straight down. So I'm reading this value off. Remembering it goes up in 2.5, so that's 52.5, 55, 57.5, and that would be 60. Part C. Use a graph to find an estimate for the interquartile range of the heights. So how do we work out interquartile range? All we need to do is find the upper quartile minus the lower quartile. The upper quartile is the top 25% of the data, and the lower quartile is the bottom 25%. Well, this is the top 3/4 and the bottom 1/4. So let's find 3/4 of 80, because there's 80 plants altogether. 3/4 of 80 is going to be 60, and 1/4 of 80 is going to be 20. So we need to find my 60th value and my 20th value, and then we'll take them away from each other. So we'll read both of those on the graph. Drawing a line from 60, and that's down to 75. So that's telling me my upper quartile is 75, and my lower quartile I need to read off at 20. Draw my line down. This value here is 37.5, so that would be 40. So minus my lower quartile minus 40. So just rewrite that down below. So 75, take away 40, which is equal to 35 centimeters. That's my interquartile range. That shows me the spread of the data. Alan also grew plants of the same type inside. So these plants that we saw in the cumulative frequency graph, those were outside. The interquartile range of the heights of these plants is 30 centimeters. Give one comparison between the distribution of the heights of the plants grown inside, which is these ones, with the distribution of the heights of the plants grown outside. That's that. So we can say the heights of the plants grown outside are more varied because there's a greater interquartile range, as the interquartile range is greater. Question 14. Here are the first 6 terms of a quadratic sequence. Find an expression in terms of n for the nth term of the sequence. First, I'm going to rewrite this below: 5, 11, 21, 35, 53, and 75. First thing I need to do is find my second difference. So the first difference between 5 and 11, there's 6 numbers between them. Between 11 and 21 is 10. Between those two is 14. And you can see it's going up by 4s every single time. So that would be 18 and that would be 22. My second difference is the difference between these two. So between 6 and 10 is 4. And you can see it's 4 all the time. I need to divide this number by 2. And this tells me the number before my n squared. So the sequence, part of it will be 2n squared. I'm going to write out my sequence for 1n squared, or my square numbers, which are 1, 4, 9, 16, and 25, and that will just help with writing the sequence for 2n squared. So if I just double all of these, I've got 2, 8, 18, 32, and 50. I need to next find my difference between 2n squared and my original sequence. So I'm going from there to there. What have I done to get from there to there? I've added 3. And then from there to there, I've added 3. And if you take a look, it's always adding 3. So this one's quite simple. It's just adding 3 on every time. We're just going to combine both of those parts. So the sequence is 2n squared plus 3. One way you could check it, let's say, for instance, you want to check this term, one term later on in the sequence. Here, n is 5 because it's the 5th term. I would substitute 5 into here, and it should give me a result of 53. Question 15. The diagram shows triangle ABC and triangle AED. Show that triangle ABC and triangle AED are similar. So let's first draw out both of these triangles so we can see it a little bit more clearly. That's my first one, and this is my second one. I'm going to label my sides. So the first one, the smaller one, I've got A, D, and E. And I can see AE is 21.6 and A to D is 32. I don't have D to E, so I'm going to leave that one blank. I'm going to do my larger triangle, so let's label the points first. I've got A, C, and B as the top. I need to find AC first, so I need to add up both of these lengths together. So I'm going to do 21.6 plus 58.4. That gives me 80, so that base is 80. Then the same thing with A to B, 32 at 22, so that would be 54. So if two triangles are similar, that means everything in one triangle has been multiplied by the same value to get to the other triangle. It's just an enlargement of the first triangle. So let's first think, if I've got 32 times by something to get to 54, what would that number be? So I'm going to do 54 divided by 32, which, let's see what that gives me. 54 over 32, which is 1.6875. I'm going to do the same thing with that one, 80 divided by 21.6. And hopefully it gives me the same number. But if you take a look, it doesn't give me the same number. So 3.70. That means that's incorrect. These sides are not matching up with each other. So I'm going to try it with different sides. I'm going to try these two sides together, and I'm going to try these two sides together. And hopefully they'll have a matching length scale factor. So let's do 54 divided by 21.6 this time. 54 over 21.6, which is 2.5. And if I do 80 divided by my 32, let's see what that gives me. Hopefully it's 0.5 again, and yeah, it's 2.5. So they have the same length scale factor. That means they are similar, they're enlargements of each other. So we can say the triangles are similar as they have the same scale factor of 2.5. Question 16. Zia has to set a 4-digit security passcode on her phone. Each digit of the passcode is a number 1 to 9. She can use each number more than once. Zia tells her friend, Amber, that the first digit is a cube number. What are our cube numbers between 1 to 9? So the first cube number is 1, 2 times 2 is 8, and 3 times 3 times 3 will be 27. So that'd be too big. The second digit is a prime number. So our prime numbers are numbers with 2 unique factors. The first one is 2, and then we have 3, 5, 7, 9 is our prime number. The third digit is greater than 6, so it can't be 6, so it has to be 7, 8, or 9. The fourth digit is an odd number, so it has to be 1, 3, 5, 7, or 9. The diagram shows one possible 4-digit passcode. Amber is going to have one attempt at guessing Zia's passcode. Work out the probability that Amber guesses Zia's passcode on the first attempt. So let's think, how many options do we have altogether? For the first number, we have 2 options. For the second, we have 4. Third digit, we have 3, and then we have 5 options for the last one. If we multiply all of these, that'll tell us how many possible combinations there are. So it's 2 multiplied by 4 times by 3 times by 5. So 8, 24, that'd be 120. So altogether, there's 120 possible combinations, but we need the probability that she's going to guess it right first time. So it's going to be 1 over 120. Question 17. Write x squared minus 8x plus 3 in the form x minus a squared minus b, where a and b are integers. If you see something like this, that means we're completing the square. We're going to half this term here first. So we're going to have x minus 4 in brackets because that's an x and that's squared. And whatever 4 squared is, we're going to take that away because right now, if we expanded this out, we would have an extra plus 16. So we want to take away 16. And we've still got this plus 3. We're just going to clean up this little bit. So we've still got x minus 4 in brackets squared. Minus 16 and 3 would be minus 13. So that's my final answer. And if you did expand this out, you would get that. Hence, write down the coordinates of the turning point on the graph y equals x squared minus 8x plus 3. And if you look, this is part 2 of a 2-part question. So it's going to refer to this part, this expression. If we think about the graph of y equals x squared, its turning point is at 0, 0. So this graph has just been transformed in 2 directions, and we need to figure out how this turning point of 0, 0 has been moved. This part is telling me how it's moved in the x direction, and it's the opposite of what you're thinking. So there's a negative 4, but it's actually moved right by 4. And this says minus 13, so that means it's moved minus 13 in the y direction. So this turning point of 0, 0, it's gone to 4, and then it's gone down to negative 13. So the x coordinate will be 4, and the y coordinate would be negative 13. Part B, solve 7x squared plus 8x minus 5 equals 0. Give your solutions correct to 3 significant figures. If you see something like this, and you've got a quadratic where the highest power is a 2, that means you're probably going to be using the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's just figure out what a, b, and c are. So a is the coefficient, the number before the x squared, which is 7. B is the coefficient before the x, which is 8. And c is the constant, the bit on its own, so it's negative 5. I'm going to substitute all of these into here, and we'll get 2 solutions. And it gives you a clue, it's solutions, not solution. So first we've got minus b, so it's minus 8, plus or minus the square root of b squared, which is 8 squared, minus 4 lots of a, which is 7, and c, which is negative 5, all over 2a. A is 7. Let's concentrate on this little bit here first. So we've got 8 squared minus 4 lots of 7 times by negative 5. That gives me 204. So we've got minus 8 plus or minus the square root of 204 being divided by 14. So we're going to have 2 answers, negative 8 plus root 204 over 14, and the other answer is negative 8 take away root 204 over 14. We'll do the plus one first. Got negative 8 plus root 204 over 14. That gives me 0.4488. I'm going to do the other one where it's a minus, and if you can go back on your calculator, you can just change that to a minus. And I've got negative 1.5916. Here we want these answers to 3 significant figures. So significant just means the first one that isn't a 0, the first non-zero digit. So we're going to count after this 4, 1, 2, 3. So our line would go between these 2 8s. That means we would be rounding this to 0.44. It would go up to 449. So 0.449 is our first answer. The other one, we would start from here, 1, 2, 3. Line would go between the 9 and the 1. So that would just stay as it is to minus 1.59. Alex has to find the solutions of the quadratic 3k squared plus 10k minus 8 equals 0. Here is his working and answer. 3k minus 2 brackets k plus 4 equals 0 and k equals 2 or k equals negative 4. What mistake has Alex made? So let's just take a look at this. If I expand this bracket out, do I get this? So let's do 3k times by k, which is 3k squared. 3k times by 4, which is plus 12k. Negative 2 times k is take away 2k. Negative 2 add 4 is negative 8. If you combine these two together, you get 3k squared plus 10k minus 8. So he's done the first bit correctly. He has factorized it. We'll look at the next bit. We've got two numbers that multiply to make 0. So one of them will have to equal 0. We're going to do 3k minus 2 is equal to 0. And k plus 4 is equal to 0. This one's a little bit easier, so we'll do that first. Take away 4 from both sides. K is equal to negative 4, so that bit's correct. If we take a look at this one, k is being multiplied by 3, and then we take away 2, so it would be 3k is equal to 2. And if we divide both sides by 3, we get k is equal to 2/3. So he hasn't solved this part correctly. And so we found that k is equal to 2/3, so the mistake is over here. He's just thought that you can take the positive of this number, but he's forgot to divide it by 3. Question 18. Enlarge triangle P by scale factor of negative 1.5 with center of enlargement negative 2, negative 1. So negative 2, negative 1 is over here. Label your image Q. Trying to multiply all of our lengths from our center of enlargement by negative 1.5. So we'll multiply it by 1.5 first, and we'll just do the opposites of that. I'm going to take a look at this point first. From here to here, I've gone up by 2, and then I've gone across by 4. So up by 2, and then across by 4. Because I've got up by 2 and across by 4, I need to do the opposites of that, but times it by 1.5. So I'm going to go down, and I'm going to go right to get this point. 2 multiplied by 1.5, 2 multiplied by 1 is 2, and 2 multiplied by half is 1, so 2 add 1 is 3. Or you could just do 2 plus half of 2. And 4 plus half of 4 is 6. So we need to go down by 3, so 1, 2, 3, and then go across by 6. 1, 2, 3, 4, 5, 6. So that's that one done. Let's do another one. We'll do this point. This time we went up by 2, and then we went across by 6. So we need to multiply both of those again by 1.5. So this 2 will become 3 down. We're going to go right. 6 times 1.5 would be 9. So we're going to go 3 more than this. 1, 2, 3. So that would be over there. Last one we need to do is this one. So we've gone up by 1, 2, 3, 4, 5, 6. And then we're going across by 1, 2, 3, 4, 5, 6. Multiplying both of those by 1.5, we've got 9 down. And then we're going 9 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to just join up all of those. Obviously, you do this in pencil just in case you make any mistakes. And that's our image. One way you can check this, if you multiply these sides by 1.5, 2 times 1.5 would give you 3. And for this one, where the length is 4, if you multiply that by 1.5, that would be 6. So 1, 2, 3, 4, 5, 6. So that looks correct. Last thing that we need to do is just label our image Q. Triangle P is transformed by a combined transformation of a rotation of 90 degrees anti-clockwise. So clockwise is going that way. Anti-clockwise would be going that way. About the origin, origin just means the center, 0, 0. Followed by a translation. Translation just means that it's been slidden across to give triangle R. Exactly one vertex. Vertex just means corner or point of triangle P is invariant. Invariant just means that after we've done this transformation, the point will be exactly the same. It won't have changed under the combined transformation. Find one possible column vector for the translation. First thing that we're going to do is do this rotation of 90 degrees anti-clockwise. It's about the origin. So to do this rotation, you'd put your tracing paper over P, you draw around P, keep your pencil on the origin, and you'd turn your paper, your tracing paper, 90 degrees anti-clockwise, so it's in this direction. And your final answer should look like this. So you'd have a 1 point here, 1 point here, and the final point would be over here. Just join that up. So we've done part of the question, we've done the rotation. I'll just label that R for now. The next thing that we need to do is this translation. So we need to slide it so that exactly one of the points is exactly in the same place. So I'm going to choose this corner over here just because I think it's the easiest. So I'm going to move this along and I want it to end up here. So from here to get to here, I've gone from -1 to -8. So I've taken away 7. I've gone 7 to the left hand side. And from here To get up to here, I've gone from -8 up to 1, so I've added 9. So I'm going up by 9. So my column vector would be -7, 9. Question 19. The diagram above shows a frustum f of a cone. The frustum is made by removing a cone with height 10 centimeters. So the height of this small cone is 10 centimeters. From a solid cone with height 15 centimeters and base diameter 24 centimeters. So I can also put that this height is 15 centimeters and they've told me that the diameter is 24 centimeters. The solid S is made by removing F from a solid hemisphere as shown in the diagram below. So we've got this hemisphere and they've got this frustum and they've removed this frustum from this hemisphere. The hemisphere has a diameter of 24 centimeters, that's already on. Calculate the volume of solid S. Give your answer correct to 3 significant figures. Let's first concentrate on finding the volume of this frustum. So we've got the diameter of that larger frustum. We'll find the radius of it because all of these formulas are using radius. 24 divided by 2 because the radius is half of the diameter. 24 divided by 2 would give me 12. So that length is 12. And now we need to figure out what this radius of this smaller cone is. So how would we find the scale factor going from the larger cone to the smaller cone? I'm going to do the large height divided by the small height. So 15 divided by 10, which is 1.5. So this 1.5 is telling me that the small cone is multiplied by 1.5 to get to the larger cone. Because we know the larger cone's radius, I'm going to divide this by 1.5. So 12 divided by 1.5, and that will give me my radius of this smaller cone. 12 divided by 1.5 is 8. Now I've got my radii for both of these and I've got my heights for both of these. We just need to substitute all of these into here and then take away the larger one from the smaller one. So we'll do the larger one first. So the volume of the larger one is equal to 1/3 pi r squared h. So 1/3 pi multiplied by my radius. My radius is 12 squared times by my height, which is 15. Type all of that in. I know 1/3 times 15 is 5. So I'll just do 5 pi multiplied by 144, which is 720 pi. That's 720 pi. I'm going to do the small one. So same as before, 1/3 times by pi times by r squared. The radius here is 8 and the height is 10. So 8 squared times by 10. I know 8 squared is 64. 64 times 10 is 640. So it's 640 over 3 pi. Obviously, you can type all of this into your calculator. So now I've got my large one and my smaller one. To find the volume of the frustum, I need to do the large one, take away the small one. So volume of the large, take away the volume of the small one. So that's 720 pi minus 640 over 3 pi. So 720 pi minus 640 pi over 3, which is 1520 pi over 3. 1520 pi over 3. We've done our frustum, so I'll just circle that because we'll need it later. Next, we need to find out the volume of this hemisphere. So we've got the formula for a sphere, but we need to find a hemisphere, so we're just halving whatever value we get for this. So let's substitute these values in. So the volume of the sphere is 4/3 pi r cubed, 4/3 multiplied by pi multiplied by r cubed. Here, the diameter is 24, so the radius will be 12 centimeters. So 12 cubed. Type in all of this in. So we've got 4/3 pi multiplied by 12 cubed, which is 2,304 pi. We've got the volume of the sphere, but we need the volume of a hemisphere, so we just divide this by 2. So that's 1152 pi. The last step that we need to do is take away the volume of the frustum from the volume of the hemisphere. So it's volume of the hemisphere, take away volume of the frustum, which is equal to 1152 pi minus 1520 pi over 3. So 1152 pi minus 1520 pi over 3. That gives us 1936 pi over 3. And it wants it to 3 significant figures, so I'm just going to write this as I can see it on the calculator, which is 2027.374. 2027.374. Want it to 3 significant figures, so we count 1, 2, 3. Line would go here between the 2 and the 7. The 7 is telling me that I need to round up, so it would become 2030. This would be in centimeters cubed because it's a volume. So 2030. Question 20. The turning point on the graph y equals g of x has coordinates -3, 6. Write down the coordinates of the turning point on the graph y equals g of x minus 7, and the minus 7 is inside the bracket. It's opposite of what you're expecting, so because it's minus 7, you would think it's moving left in the x direction, but it's actually moving right in the x direction. So we need to add 7 to this -3. So -3 add 7 would be equal to 4. It's moved right by 7, so it's 4. The y coordinate is going to stay exactly the same, so it's just 6. The graph of y equals f of x is shown on the grid. On the grid, sketch the graph of y equals f of minus x plus 3. Because the negative is inside the bracket next to the x, that means it's a reflection in the y-axis. And this plus 3 is outside the bracket, so that means it's moving up in the y direction by 3. First thing that I'm going to do is this reflection in the y-axis. I'll do this in a different color. So I'm going to reflect 3 points, these two minimums and this turning point in the y-axis. So this one is at -6, so it's going to move over here to -6. This one is at 2, so it'll move to -2. This one is at -2, so it's going to move to 2. Next thing that I need to do is shift all of these up by 3. So this one is going to go up by 3, 1, 2, 3. This will go up by 3, 1, 2, 3. And this will go up by 3, 1, 2, and 3. So I just need to connect all of these red points up together. Just do this using the curve of your hand. You want a smooth curve going through all of the points. So the last thing that I would do is just label all of these points that we've got. So we've got -2, -4, 6 and -4, and 2 and 6. And the examiner will look at these 3 points just to check that they're correct. So that just helps them. Question 21. A, B, C, and D are points on the circumference of the circle, center O. AC is the diameter of the circle. So ADE is a straight line, and BCE is also a straight line. I can see I've got a triangle here, and I can see I've got another triangle over here. Work out the size of angle BDC. So we're trying to find B to D to C, which is this angle over here. Write down any circle theorems that you can use. The first thing that I can see is that I've got angles in the same segment that are equal. It's the bow tie theorem because it looks like a bow tie. This one is 35. That one will also be 35. So I'm going to write DBC is equal to 35 as angle in same segment are equal. It told me that AC is a diameter. So if I just think about this, I've got a semicircle going on here. That tells me that this angle is a 90-degree angle. So I'm going to write ADC is equal to 90 as angle in a semicircle is 90. Next thing that I can see is this triangle over here. I've got 2 of the points. I can find out what this missing angle is here, this larger one. So I'm going to try and find what this angle is, this large vertex, BDE. So BDE is going to be 180 minus 35 and minus 28. That will tell me what it is. So 180 minus 35 minus 28, which is 117, as angles in a triangle add to 180 degrees. Now I know that this blue angle is 117 degrees. I could also say that because that's a right angle and this is a straight line, this will also be 90 degrees. So I'll just write CDE equals 90 as angles on a straight line equal 180. The final thing that I need to write is BDC, the angle that we're trying to find, is equal to BDE minus CDE, which is 117 minus 90. That gives me a final answer of 27 degrees. Question 22. Ebony makes some bracelets to sell. The materials to make all the bracelets cost £190, correct to the nearest £5. Because this is a question that's concerning error intervals, I'm going to write all of my error intervals before I read the full thing. So to write error intervals, I'm going to take my original number and plus and minus my limit of accuracy That's just whatever it's been rounded to, divided by 2. So for this first one, it's the materials, which is 190 plus and minus, and it's been rounded to the nearest 5. So I'm doing plus and minus 5 divided by 2. 5 divided by 2 is 2.5. So for the lower bound, 190 take away 2.5 would be 187.5. And for the upper bound, it's going to be 190 plus 2.5, which would be 192.5. That's that one done. Ebony sells all the bracelets for a total of £875, correct to the nearest £5. So I'm going to do the same thing for this. I'll just call this my revenue, which is equal to 875 plus and minus 5 over 2 again is equal to, that'd be £872.50 for my lower bound, and my upper bound would be £877.50. The total time taken to make and sell all these bracelets was 72 hours, correct to the nearest hour. We'll do this as well. So the time is going to be 72 plus and minus, because it's to the nearest hour, we're going to do 1 divided by 2. So the lower bound would be 71.5 hours and the upper bound would be 72.5 hours. Ebony uses this method to calculate her hourly rate of pay. The hourly rate of pay is the total selling price, which is this revenue, minus the total cost of materials, that's that one, divided by the total time taken, that's that one. The minimum hourly rate of pay for someone of Ebony's age is £8.20. By considering bounds, determine if Ebony's hourly rate of pay was definitely more than £8.20. Show all your working. This is just asking us what's the minimum amount of money that we would get if this is the amount of work that we're doing. So we're trying to minimize this. So if we've got something that's being divided by something else, how would we make this the smallest number possible? On the top, would we want a large number or a small number? We're going to want a very small number on the top, and on the bottom, we're going to need to use a very large number because we want to divide it into as many pieces as possible. But just concerning this top one, if we want to make this as small as possible, we're going to make this number as small as possible. So we're going to choose our lower bound for our selling price, but for the total cost of materials, we're going to choose our upper bound for that one because we're trying to minimize this numerator. For the bottom, we're going to choose our upper bound. So the total selling price, we're using the lower bound, which would be £872.50. It's that one. Minus the total cost of materials. We want the upper bound, so we're going to choose that one, minus 192.5, over, we want the upper bound for the total time taken, so we're going to choose this one, 72.5. And then we'll compare it with £8.20. So 872.5 minus 192.5 over 72.5. That gives me an answer of 9.3793. So this is telling me that even if the amount of work that she's doing is minimized, the value that she's earning is as low as possible, she's still earning more than £8.20. I'm going to choose to truncate this to £9.37 because it's pound and pence. And the final step that we need to do is compare this value with £8.20. So we can see that 9.37 is greater than £8.20. So therefore, Ebony will always earn more than the minimum rate of pay. Question 23. Given that 2x squared plus y squared over 4x squared minus y squared is equal to 43 over 1, where x is greater than 0 and y is greater than 0, find in its simplest form the ratio x to y. So I'm going to ignore all of this. I'm just concentrating on solving this equation for now. So I've got 2x squared plus y squared over 4x squared minus y squared is equal to 43 over 11. First thing that I need to do is cross multiply to get rid of these fractions. So I'm multiplying all of this by 11. So that would become 2x squared times 11, which becomes 22x squared plus 11 times y squared is 11y squared is equal to, and I'm going to cross multiply here as well. So I'm doing 4 times by 43 first, which is 172x squared minus 43y squared. I've removed that fraction, so now I need to move all of the x squareds to one side and all of my y squareds to the other side. Because I can see I've got more x squareds here, I'd rather move this 22x squared to this side, and I'm going to move this minus 43y squared over to this side. So I'm adding 43y squared here, and I'm taking away 22x squared here. So this is going to disappear, and this will disappear. 11 add 43 is 54y squared is equal to 172 take away 22 is 150 x squared. I want to bring all of my numbers onto one side and all of my letters onto another side. So I'm going to do two things at the same time. I'm going to divide by 150 on both sides, and I'm going to divide by y squared on both sides. On the left hand side, I'll have 54 over 150, and on the right hand side, I've got x squared over y squared. So that 150 has disappeared as well. I'm going to simplify this fraction, so I've got 54 over 150, which is the same as 9 over 25. So x squared over y squared is equal to 9 over 25. If you take a look at all of these are squares. So x is a square, y is a square, 9 is a square number, and 25 is a square number. So I'm going to square root all of this. Square root in the left side would give me x over y is equal to square root of 9 is 3, and square root of 25 is 5. We need to write this in the form x to y. If I think about the fraction 1/2, that's the same as 2/4. So I could write this 1/2, 1 to 2, that's the same as 2 to 4. So 1 to 2, x to y, is the same as 3 to 5. Question 24. The diagram shows a triangular prism with a horizontal rectangular base ABCD. M is the midpoint of AD, so that's at the middle of AD. The vertex T of the prism is vertically above M, so that's a straight line. AB is 14.7, so there to there is 14.7, so I'll label that on. B to C is 3.8, B to C is 3.8, and that would mean that this is also 3.8. M to T is 2.3, M to T is 2.3, and P is on the point AB such that A to P to P to B is 5 to 2. So P is somewhere about here, and the ratio is 5 to 2. So this is 5 parts out of a total of 7, so it's 5/7 of the line, and this is 2/7 of the line. So I'm going to write what AP and PB are. So AP will be 14.7 multiplied by 5 over 7, which is 10.5. So that part is 10.5. And this part of the line, you could do 14.7 times 2/7, or you can do 14.7, take away 10.5, which is 4.2. So that part is 4.2. You can rub out those because we don't need them anymore. Calculate the size of the angle between TP, so TP is this line here, and the base ABCD of the prism. So we're going to draw a triangle over here, and we're trying to find this angle. Give your answer correct to one decimal place. Let's draw this triangle TMP out. So I've got T, M, and P. And I know that this height is 2.3. I'm trying to find what this angle at P is. And do I know any other piece of information about that? No, I don't. So I need to find another triangle where I could find some more information. I could see this triangle. So AMP, and I'll draw that out. What pieces of information do we know about that? I know M is the middle of DA, and that length is 3.8. So this part will be half of 3.8, and this part will be half of 3.8. 3.8 divided by 2 would be 1.9. So this length, MA, is 1.9. I also know that AP is 10.5, so I can put that on. And if I find this length, MP, I could also put it onto this triangle as MP. So I've got two sides. It's a right angle triangle, so all I need to do is Pythagoras. That's a squared plus b squared equals c squared. Or I could just think I'm finding the longer side, so I need to square both of these, add them together, and square root it. So I'm doing 10.5 squared plus 1.9 squared, and square rooting all of this. 10.5 squared plus 1.9 squared, all square rooted, which is 10.6705. I know MP is 10.7, so I can also put that over here. So 10.6705. I'm trying to find out this angle, so I'm going to be using trig. I've got two other sides and I need an angle. So let's label these sides. This is a right angle, so the side opposite the right angle is the hypotenuse. The side opposite the angle that we're trying to find is the opposite, and that's the adjacent. Because we have A and O, and we're trying to find an angle, which of these are we going to be using from SOHCAHTOA? Has O and A, so we're going to be using tan. So tan of theta of tan of x is going to be the opposite over the adjacent. So the opposite is 2.3 over 10.6705. To move this tan to the other side, I'm going to do x is equal to the inverse tan of 2.3 over 10.6705. That will give me that angle. So I'm doing inverse tan because I'm finding an angle. The fraction is 2.3 over my previous answer. That gives me 12.1638. I want my answer to one decimal place, so I'm going to put my line between the 1 and the 6, and that means I'm rounding up to 12.2. That's to one decimal place. That's the end of the questions for today. I recommend you go through all of the questions and write down the topics that you struggle with and focus on revising them before you start another past paper. Feel free to contact or reach out to me if you need any help with anything. Otherwise, you can find more work solutions and more past papers on my channel, including the ones from this year's set. I'll see you soon.